Jai Hind dear students, welcome back to this video. As you all know, we are doing exercise 6.3 and yesterday we have done some questions and also have done one part of question number 6. So let's learn more about this exercise. Let's see how to do rest part of question number 6 and more questions. So starting with question number 6. So this parts we have already done. So starting with the fourth part. In fourth part we have 2645. We are finding the smallest whole number by which it should be divided so as to get a perfect square. So what was the next step? Yes, we are going to find prime factorization of 2645. Since this is an odd number, so using divisibility rule to check if it is divisible by 3 or not. So if you will sum up, so the sum of the 4 number is not the multiple of 3, so it will not be divisible by 3. Moving to next number, that is 5. So if we will check for 5, yes, it is divisible. So 5 times 5 is 26, then 2 and 9. Now again we have to think that which number can divide 529 using divisibility rule. So to check by which number we can divide 529, or if you will find the prime factors of 529, so you will see that this number is not divisible by 2 as well as not by 3, 5, 7, 11, 13, 17 and 19. None of these are factors of 529. So the prime number that is the factor of 529 is 23. In fact, I would say that 529 is a perfect square of 23. So if you will divide 529 by 23, we will get 23. And 23 times 1 is 23. Right? So what was our next step? We will write all the factors of 2645. So all the factors are 5 into 23 into 23. Now we are going to find the pairs. We will see that 23 is in the pair but 5 is unpaired. So what you can do? We can remove this 5, right? So for that we need to divide 5 from 2645. So if you will do that, we are left with 23 square only, right? So the square root of, if we will divide 2645 by 5, we will get 529. So we'll say that square root of 529 is 23. So the smallest whole number by which it should be divided is 5, and square root of the square numbers obtained is 23. Clear? So in this way we will solve this part. Now let's move to sixth part that we have to do in our classwork. So for this we have 1620 as our number. So let's find prime factorization of this number. Since this is an even number, so we can divide it by 2. So the smallest prime number that we are taking is 2. So 8 times 16, 1 and 0. Again this is an even number, so 2. 4 times 8, 0, 5. Now this can't be divisible by 2, right? So moving to next possible prime number. So next is 3, as it is divisible by 3. 3 times 1 is 3, 3, 5. Now let's check by divisibility rule. Yes. So dividing by 3 again, 4 times 12 and 5. Again it is divisible by 3. So 3 times, if you will add 4 plus 5, you will get 9. So this is divisibility rule of 3. So now we got 15, and as we know 15 is also divisible by 3. So 5 and rest we will finally take 5. So 5 times 1 is 5. Now what is our next step? Yes, we will write all the factors of 1620 and then we will find pairs. So it's 2 times 2 into 4 times 3, right? So we are going to write 4 times 3, 3 into 3 into 3 into 3 and 1 time 5. So now if we will pair up the prime factors, this is our first pair, second pair of 3, third pair of 3. But again 5 is having no pair or it is unpaired. So to remove this we are going to divide this number by 5. Clear? And now we are left with pair numbers. So we will get perfect square number through this. We are going to take 1 out of each pair. So we will write it as 2 into 3 into 3, this 3 whole square, right? So if we will divide 1620 by 5, we will get 324, right? So the square root of 324 is, we will just take 1 out of each. So 2 into 3 into 3, this we are going to take. So 2 into 3 into 3, it will give 2 times 3 is 6, 6 times 3 is 18. Clear? So now we can say that square root of 324 is 18. The smallest whole number by which it should be divided is 5 and square root of the square number so obtained is 18. I hope so you have understood, and in this way we will solve this type of question. The question will become more easier if you will understand the main concept behind that, right? So let's move to question number 7. Question number 7 statement says the student of class 8 of a school donated rupees 2401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. We have to find the number of students in the class. So there are two unknowns in this situation. First, the number of students and the amount of money they have donated. But we are told that these two are equal. We have given that each student donated as many rupees as the number of students in the class. So this is the important part of the problem statement. So let's assume the number of students. We can take any variable, right? So assuming that the number of students are, let's take the variable to be x. So the number of students we have assumed as x. Clear? And it also means that each student have donated this many rupees, x rupees, right? As it is also given in the question that each student donated as many rupees as the number of students. So donation by each student will be equal to rupees x or x money, that is equal to number of student. So now total donation made by the x students, so total donation will be equal to, you have x students and each students donated x amount of money. So total donation will be x into x, rupees x. Clear? Or it will be equal to rupee x square. So the total donation is rupee x square, these many rupees. But we also know that the total donation from the class was rupees 2401, right? So according to question we can write that rupee x square is equals to rupee 2401, and which basically means that x square is equals to 2401. So now we have to find the value of x, and x value will be equal to square root of 2401. I hope so you have understood this point. Now we have to find the square root of 2401. And to do that, we are going to prime factorize this number. Clear? So we are going to find prime factorization of this, and then we will be able to find the square root. Now, as you can see, this number is not an even number. So the smallest prime number that we can take to divide is 7. Clear? Using divisibility rule we have find, and we will get 343. Again it is divisible by 7. So we will get 4 times 28 and 9. Again divisible by 7. So 7 times 7 is 49 and 7 times 1 is 7. Clear? So what we get is the prime factorized form of 2401 is 4 times 7. That is 7 into 7 into 7 into 7. Now what was our next step? Yes, we are going to split it into pairs. So now we can write it as 7 times 7 whole square, or we can take one number out of each pair. So our final result will be the square root of 2401 is equals to 7 into 7. So here we can write the square root of this is 7 into 7, that is equals to 49. Understood? Therefore we can see that the number of students in the class was 49 and the donation by each student was 49 rupees. So the answer for this question is 49 students, and in this way we will solve this type of questions. So for better understanding, try to do more practice of statement type questions. I hope you have understood this part. Now let's learn how to solve question number 9. In question number 9, we have to find the smallest square number that is divisible by each of the numbers, that are 4, 9 and 10. Basically, we need to find the smallest square number which is the multiple of each of these numbers 4, 9 and 10. So here's how we will solve this question. We will do in 2 steps. In first step, we are going to find the LCM of these 3 numbers, that are 4, 9 and 10. And in the second step, we will find the multiplier by which to multiply the LCM to make it into a perfect square. So the resulting number that we'll get after step 2 will be multiple of all these 3 numbers and also will be a perfect square. Now let's start with our solution. Starting with step 1, we are going to find the LCM of this number. So writing the prime factors of each of this number, for 4, as we know, it is 2 into 2. Prime factors of 9 is equals to 3 into 3, and for 10 it will be equal to 2 into 5, right? So from this we can write the LCM easily. So LCM will be equal to the maximum number of 2 occurred in any of the number is 4, so we will write 2 repeated twice. Now maximum number of 3 is also 2, so the LCM will be into 3 into 3. Now the maximum number of 5 occur is 1 in the number 10, so we will write into 5. And I hope you have understood this point, how to find LCM. Now we are going to find the product. So 2 into 2 into 3 into 3 into 5 will be equals to 4 into 9, that is 36, and 36 into 5 is 180. But we will be basically using the prime factorized form of the LCM for next step. So in next step, we need to find the appropriate multiplier to make a perfect square, right? So the LCM once again is 2 into 2 into 3 into 3 into 5. Now if you will pair up the prime factors, you have pair of 2, pair of 3, but this 5 is left unpaired. So by what number you should multiply the LCM so that you can get a perfect square? And yes, that number should be 5 so that you can complete this unpaired part of 5. So if you will multiply the LCM by 5, what you will get? Yes, 2 into 2 into 3 into 3 into 5 into 5. Clear? So now we can say that this number is a perfect square because it is having pair of 2, 3 and 5. And because it is a multiple of the LCM, it is also a multiple of all the three numbers, that is 4, 9 and 10. So this is the number we want. The smallest number which is a multiple of all this number 4, 9 and 10, and which is also a perfect square. So let's find the number. It is 4 times 9 times 25. We are just multiplying it. Now 4 9 times is 36 and 36 times 25 is 900. Or you could just take the LCM into 5. So LCM was 180 and 180 into 5 will gives you 900 only. So the smallest such number is 900, and in this way we will solve this question. I hope you have understood all the questions that we have discussed today. Also, I suggest please try to solve all the questions by yourself also. We will learn more in our next class. Till then, take care and thank you.